Okay, let's have a look at question 2. Okay, so question 2 is your standard organic chemistry question. So let's jump straight into it. Okay, so just to clarify everything, I've drawn out all those compounds there. So we have A, B, C, D, E, F, G, and H. Okay, so it's always convenient just to draw them out before you start with the questions, so that makes things a little bit easier. Okay, but let's jump into the questions. So question 2.1 says define the term unsaturated compound. Okay, so unsaturated compound is just compounds with more than one single bond okay, let's do it this way, with a at least one multiple bond between one carbon, or between two carbons, sorry. Okay, so what do I mean by that? An example would be looking at number B. Okay, so B has a double bond between two carbons, therefore it makes it an unsaturated compound. Okay, now if we look at 2.2, it says write down the letter for the following. Okay, the letter that represents an unsaturated compound. Okay, so I gave it away there. So for 2.2, we are going to be looking at B and E. Okay, so E's also got a double bond because it's C2H4. Okay, so the answer there is going to be B and E. Okay, and that will give you your 2 marks over there. Now, 2.2.2 says name the functional group of compound C. Okay, so if we go to compound C, I've drawn it out over here. Okay, so we can see we've got that carbon attached, the oxygen double bonded to a carbon that sits between two carbons. Now, any group that has a double bond oxygen, okay, that's not on the end, we call those our carbonyl groups. Okay, so 2.2.2 is just your carbonyl group. Okay, now 2.2.3, the letter that represents the chain isomer of C. Okay, so what is an isomer? Remember, it has the same number of atoms or molecular formula, but now it's a chain isomer, which means all we've done is we've shifted the chain. So if we're looking at compound C over here, okay, I've shifted the chain, okay, so that there would be a chain, or we can make a chain with one of these atoms over here. So if we look over here, okay, if we look at F, okay, I've also got the oxygen double bonded, and all I've done is I've taken off one of the carbons, okay, and I've attached it to form a chain, okay, hence chain isomer. So your answer for this one is F. Okay, so 2.2.3, your answer is F. Okay, now 2.2.4 says the IUPAC name for compound G. Let's have a look at G. Okay, so G has 2 chlorines attached to it, plus it's got this CH3 chain attached to it. So remember your IUPAC rules, you always start counting from the side which will give your chains the least number. So if I count from the left, okay, this will be 1, that will be that will be 2, can't count today. This will be 3, 4, and that would be 5. Whereas if I count from the right, that's 2, 3, 4, 5. Okay, so counting from the left gives me the lower numbers. So let's have a look at how we're going to write this. Okay, so first of all, note, let me put that over there. Okay, how many carbons are we dealing with? 1, 2, 3, 4, 5, 6 in my longest chain. Okay, so 6 carbons means it's going to be hex. Okay, notice that everything is single bond, so it's hexane. Okay, so that's the back end. Okay, now let's have a look. We always put our halides first before we put the side chain. Okay, so there are 2 chlorines. Okay, so we need to say where they are. So the first chlorine is on 2, the second one is on 5. Okay, and because there's 2, it's dichloro Okay, then we talk about the side chain over here, which is CH3, so that's a methyl side chain. So we need to say where it is, -3 methyl hexane. Okay, so let me just write that a little bit neater. So 2,5 dichloro 3 methyl hexane. Okay, and that's the IUPAC name for G. Now, 2.5.5 says the general formula for the homologous series to which compound E belongs to. Okay, so let's have a look at compound E quickly. Okay, I've drawn it over here, but there they've just given it as C2H4. Okay, so you can see that there's a double bond. Okay, but now we want the general formula for it. Okay, so because it's a double bond, it's an let's see, it's alkanes for single bond, alkenes for double bonds, and alkynes for triple bonds. Okay, so because it holds a triple bond, it's 2 carbons and 4 hydrogens. So you can see that for every 2 carbons I have 4 hydrogens. Okay, therefore my hydrogens are double that of my carbon. So the general formula is just CnH2n. Okay, all right. Now looking at 2.3 says define the term functional isomer. Okay, so what is a functional isomer? Let me just put this over here. 2.3, it has the same molecular formula. Okay, so same molecular formula. But what is different? The different functional group. Okay, so there's my question, and there's my definition. Okay, now 2.4.1, okay, we're looking at compound A. So it says the homologous series to which A belongs to. Aha, okay, so the homologous is how we're going to classify this compound. Which group does it belong to? So the key thing that you should be looking at is this double bond oxygen on the last carbon with an OH attached to the end. Okay, so this OH would normally indicate an alcohol, but we have a double bond oxygen to the same carbon, so therefore we are dealing with a carboxyl, or carboxylic, funny words, carboxylic acid. Okay, so 2.4.2 is now looking at the structural formula for the functional isomer of A. Okay, so let's go back to our molecules that we've drawn out over there. Okay, so looking at A, we've got 2 carbons, 4 hydrogens, and 2 oxygens. Okay, so we need to keep 2 carbons, 4 hydrogens, and 2 oxygens. I can't add or take away any molecules. Okay, remember it's an isomer. Therefore, we're still going to have a double bond oxygen to one of the carbons. Okay, so as I've stated here, we still need 2 carbons, we still need 2 oxygens, and we need 4 hydrogens. Okay, so one that you could do for the structural formula for the functional isomer would be this over here. So you would have carbon on the end with a double bond oxygen. Okay, but now instead of having the OH attached, I'm just going to have a single hydrogen over there. Now I'm going to attach the oxygen in the middle. Okay, and now I'm going to attach the second carbon with the remaining 3 hydrogens. Okay, alright, so I've kept the double bond. Okay, I've just shifted the oxygen to between the 2 carbons. Okay, because remember they asked for a functional isomer, so I have to change the function of it. Okay, so I've changed it from the double bond oxygen on the end with the single bond oxygen to this over here, and if I recall, this is your ester. Okay, alright, so 2.5.1 is now asking you to look at compound D, which is undergoing dehydration reaction. Okay, so what does dehydration mean? If you're dehydrated, means you need water, so we're removing water from the reaction. Okay, so 2.5.1 says the IUPAC name of compound D. Okay, let's go have a look at compound D. Okay, so I've drawn it out there. There's 2 carbons. Then we have this OH group attached to the end. This indicates that it's an alcohol. We've got 2 carbons, so therefore if we go through our little rhyme, Mary eats peanut butter, so 2 stands for the E, so therefore it's ethyl. Sorry, therefore we are dealing with, not an ethyl, sorry, we're dealing with eth because it's 2, and then the name for this, because it's an alcohol, is ethanol. There we go. Okay, so it ends in ol. Okay, ethanol, we're dealing with an alcohol. Now, 2.5.2 is asking you to write down the letter that represents the product of the reaction. Okay, so remember, we're doing a dehydration. Okay, so therefore we're removing water. So if I take this compound over here and I remove 2 hydrogens and 1 oxygen, let's say I remove this over here, what's going to be left? Okay, well, one of the hydrogens will move to this carbon and would then create a double bond. So we'll have carbon with a double bond between it, and then we'll have 4 hydrogens. So now if we're going to look at which one that represents, okay, so if we're going to look through them, we find that we are dealing with E, which is 2 carbons and 4 hydrogens. Okay, so the letter here is letter E. Now, lastly, if we look at 2.5.3, it says name the formula of the inorganic reactant that is used in this reaction. So what are we using to split this water off of this alcohol? Okay, so the answer to that one is, okay, it needs to be an acid, and there are 2 options for your acids. It's either H2SO4, okay, which is sulfuric acid, okay, or it's H3PO4, which is phosphoric acid. Okay, and that's how we go about doing question 2. Okay, if you found this chemistry video helpful, then please leave a thumbs up on the video. It does help me out a lot. Please consider subscribing down below if you are enjoying the content from this channel. If you have any questions regarding this question on organic chemistry, then please leave them down in the comment section below. I'll get back to them as soon as I can. And remember, it's never too late to have an OIC moment.